For part C, we have the quantity x to the fourth y to the sixth to the third power times the quantity 3x squared y to the fifth. Now, once again, there are lots of rules of exponents that we're going to have to use in order to do this problem. The first thing that I see is over on this left-hand side, I have a multiplication problem to a power. So that means that we have a product to a power. Product to a power rule says I can bring this power 3 down to each one of these. So let's start with that. We're going to have x to the fourth to the third power. Then we have y to the sixth to the third power. And we're still going to have 3x squared y to the fifth over on the right. Each one of these then is an example of the power rule. I have x to a power, multiply the 4 and the 3 together, we're going to get 12. Then I have y to a power, multiply the 6 and 3 together, we're going to get y to the 18th. And again, we're going to multiply this times 3, x squared y to the fifth. So now that we're here, sometimes people get a little bit confused because they think about these two chunks as a piece that cannot be separated. So they think about this as x to the 12th y to the 18th. And then they think about this as 3x squared y to the fifth. And they're pieces that are not separable. But that, in fact, is not true. So what you have to remember is that this x to the 12th and this y to the 18th are connected by a multiplication. So you can go ahead and write that multiplication dot there. And similarly here, the 3 and the x squared are connected by multiplication. The x squared and the y to the fifth are connected by multiplication. And both of these pieces, the one on the left and the right, they are connected by multiplication as well. And remember once again that multiplication is commutative. So I can move these things around and not have to worry about it as x to the 12th y to the 18th. I can think about it as an x to the 12th, another piece, a y to the 18th. So let's just reorder these factors so that factors that look alike are next door to each other. So what I'm going to do is start by putting all my factors that look like numbers out in front. The only one that I see here is a 3, so I'll start with that. And then let's go ahead and put all the factors that are x to a power. So we have x to the 12th, and that's going to be multiplied times x to the second. And then let's play the same game with the y's. We have y to the 18th times y to the fifth. So now that I have the pieces that look the same next door to each other, we can go ahead and use some rules of exponents and bring those pieces together. So x to the 12th times x to the second, that's an example of the product rule. X to a power times x to a power, I add the exponents. So 12 plus 2 is going to be 14. So we have x to the 14th. And then similarly, we have y to a power times y to a power. That's an example of the product rule again. I'm going to add those exponents. 18 plus 5 is going to be 23. So there's our final answer for this problem. 3x to the 14th, y to the 23rd. At this point, you're ready to go ahead and move on and try worksheet 27 and then homework 27 as well. Have fun.